Hello, this is the third episode of Containers series. Well, we only so far talked about dynamic array and linked list. In the first episode we talked about the differences between the two. In the second episode we've implemented dynamic array, and now it's time to implement linked list. This implementation is gonna be a template class. In this episode I'm implementing singly linked list. This means that each node has a pointer to the next node, but not to the previous one. If it did have a pointer to the previous one, it would be doubly linked list. But today we simply are gonna be implementing singly linked list. If you're not sure what linked list is, you can check out episode 1 where I talk about the theory. Here it's just gonna be practice. Let's create a separate file. Now, in the previous episode I actually forgot to put pragma ones. I did put it in here in dynamic array.h after the video. Okay, so our linked list is gonna have the following data structure. It's gonna have a node, so our linked list is just a sequence of nodes, and we have a pointer to the next node and actual data, or we could call it also data. I'll call it value, okay. And it's private, so we're not gonna actually expose raw nodes to the user of this container, because, well, just because I've decided to do so. It will be possible to kind of work with this container via iterators. So let's create an iterator which is gonna have node current, and then it's gonna have void next, which is gonna go to the next node and to the next node in the list, and it's also gonna have bool end, which is gonna return true if it's the last node in the list. Let's implement it. Node current next equals to 0, so if there is no next, then it's the end. Next simply is gonna change the current, the node that current pointer points to the current next. So these are utility data structures. This one is gonna be under the hood of the linked list, and iterator is how the user is gonna work with linked list. Okay, now it's gonna have node head, so the beginning of the list, or we'll call it front. For now it's 0, meaning null, and public. So first let's implement an insert function, void insert in front. So it's gonna insert a value into the front of the list. So it's gonna create a node and put it in the front. So first we'll have to actually create a new node. We're allocating it on the heap. Then we say node. So this will create an empty node, and an empty node is gonna have next value is gonna have next is gonna have 0, so null, and some kind of empty value. So next is gonna be front, and node value is gonna be a value. So it's that simple to insert something in the list. Next, let's create a function insert after, which is gonna insert a node after some node. So it's gonna take an iterator. So after some node, it's gonna insert a value. It's also important here to make those public and those private. And I think even though its iterator is inside of linked list, we still have to call the make it a friend, so that we have an access to private fields of iterator class. So let's extract the value, the node after which we have to insert, and then we create a new node. And so next is gonna be node next, and value is gonna be new node value is gonna be value, and node next is gonna be new node. So here so this is the node after which we want to insert. Here we create a new node and we give a next value node next. So the next of the node after which we want to insert, then we give it a value that we want to insert, and then the node next is gonna point to the new node. Also, I think I forgot to inside insert front, we have to actually update front value to be node. That's important because we insert into front, so now front has to point to node. We're gonna have a remove after. Here we get the node that comes before the node that we want to delete, and then we get node to remove, which is the next node, right? Then we update the node next to the node to remove next, so that our list doesn't break up, and then we delete the node to remove. Now I also should add a destructor, and in the destructor we're just gonna until we reach the null, the end of the list, we're just gonna delete the node and update the front value with the next one. So now all we have to do is implement get iterator function. Yeah, I forgot to actually create a constructor for the iterator. No. It's gonna probably should be a private constructor. And here we go, iterator. No, just return iterator front. There are a bunch of things that we could add. For example, we could make kind of convenience functions to swap the values between nodes, to clear the list, to get the size of the list, and so on and so on. Like we could remove from front and stuff like that. But if you understand the code that we've written here, then you will be able to implement all those convenience functions by yourself without any problem. I'm just gonna add a testing program. Yeah, of course. So we'll need a way to actually get the value from the iterator, which I forgot to add. So value is gonna return current value. So here we go. We create a linked list for std string, and until we input a string that starts with 8, the character 8 in the front, we will be inserting to the front, and we're gonna be printing out the list each time. Here is what it looks like: A, B, C, D, E, F. So as you can see, each time it inserts in the front. So if we press 8, yeah, let's stop. So it seems to be working, but now I see that this is kind of awkward because we have to. So in the iterator, we better change and to something different. For example, it will be, if it's the end, not the current is gonna be 0, but not the current next is gonna be 0, but the current is gonna be 0, and so that here we won't have to actually print the last value kind of quote-unquote manually. Let's try this out. A, B, C, D, hello 8. So A, B, C, D, hello 8, yeah. So yeah, now it's better to, so the end we're just is gonna be null, right? And so if iterator equals to end, you better not call value. I mean, if the user calls it, then exception, is gonna be thrown because it's a null. So we insert in the front, then we get an iterator, and that's how it looks. You may have seen similar notation if you used iterators working with C++ standard containers such as vector and list, forward list, queue, stuff like that. So we get an iterator and we print out. So if iterator is not the end, then we print out its value, and then we go to the next node, and yeah. Oh. Yeah, you see, that's why we're testing. So in remove after, not because iterator is not a pointer. We have to set dot and insert after as well. Yeah, let's, I don't know, and 8. So insert after the second one, insertion 1, then remove after the second one, back here. So this seems to be working fine. Also, let's test that actual deletion works. So we've inserted 3 elements, so this should delete 3 elements, or 4 elements, yeah. Okay, so the deletion works. You'll be able to find the code, everything I wrote in this episode in the GitHub repo. I'm gonna leave a link in the description. It's gonna be the first link in the description to this video. So yeah, thanks. Bye.